All right, so here we go. We're going to be doing lesson 7.6, which is the factoring of ax squared plus bx plus c. So right now, our lesson was fairly straightforward yesterday because it had we had this leading coefficient in this, right? So we have ax squared. We're going to talk about the standard form of a quadratic. Let's see, equal to 0. And this is a standard form quadratic. Okay, so these when something is a quadratic, it winds up being in this form. And what we've dealt with so far is this, where a was equal to 1 in the previous lesson. So for example, what we dealt with was x squared plus 5x plus 6 equaling 0 if we're going to solve that. And here, right, this coefficient right there is going to be a 1. But it may not always be the case. Let's actually take a look at a different one of these guys. Let's take it 4x squared plus 32x plus 60. And we're just going to factor this guy. I'm not going to even worry about solving it, okay? Now this is problematic for us because right now, when we are going to split this guy into two binomials for us to factor, I have to now deal with this 4. And what I think would be ideal is if we could actually skip a step here and not have to deal with the 4 at all. Let's actually pull that 4 out and see if it factors out of every single one of those terms, okay? And what we're going to do is rather than making it 2 binomials, I'm just going to take the entire trinomial. And I'm going to first take a 4x squared, take a 4 out of the 4x squared, which is going to leave me with x squared. I'm going to have 32, I'm going to divide by 4, that's going to leave me with an 8x. And then I have 60, which I divide by 4, and that's going to leave me with 15. Okay? And I can actually now factor this. If you guys remember, this now looks like one of these problems we did yesterday, right? Where a was equal to 1. And we're going to be able to factor into 2 different binomials. Now this 4 just doesn't disappear right here. We have to keep bringing him down, okay? If we were going to solve, of course, we divide both sides by 4. The 4 would then actually wind up getting canceled out when we divide 0 by it, but we're not doing that right now. We're just factoring. And if you guys don't believe me, again, if you want to check, redistribute the 4 into all those terms, it'll get you the original 4x squared plus 32x plus 60. Okay, and then now we need to factor this trinomial into a binomial. Okay, so of course factors of 15 that are going to have a sum of 8. Okay, factors of 15, 1 and 15, no, that's going to be a sum of 16. And then 3 and 5, that's the next one we think of. And of course 3 plus 5 is 8. So here is your answer. All right, not bad. But what if? You probably had the thought occur to you right now. What if you couldn't factor out the 4? What if you had this? 4x squared minus 7x plus 3. Actually, you know what? Before we do that one, let's do a different guy. I'm sorry. Let's do 2x squared plus 7x plus 6. Same deal where we don't have a leading coefficient that is that's 1. Now we have a leading coefficient greater than 1. So these ones I think are not bad. I really don't think they're bad because here this guy is prime. So there's a little bit of guess and check that's going to come when we factor here. Our first 2 terms have to be 2x and x. There's no other possibilities. Even if you write it as x and 2x, commutative property says, you know, it's the same thing, right? So x times 2x or 2x times x is 2x squared. So that's how that guy's going to factor out. Now, the trick is we need to take factors of 6 that when we put them in here, right, and I'm going to do this and I'm going to wind up erasing this a few times, it's going to wind up giving us the appropriate answer, right? So let's do 6 and 1, okay? Now, 6x for the inner, 2x for the outer. We already can see that doesn't work. Now, even if I switch these guys, watch what happens. If I switch the placement of them as 1 and 6, that's going to have a different yield. In fact, I'm going to get here 1x, or just x, and on the outside, 12x, and that is going to have a sum of 13x. That's a problem. That's still not 7. So I have to check for both sides, the different factors. It does matter now, the order, if I have a 1 and a 6, or if I have a 6 and a 1. Okay? So none of the iterations of 1 and 6 as factors of 6 are going to work there. Now we have to move on. So the only other factors we have are going to be 2 and 3. So let's just try them out. 2 and 3 in those places. That's going to be a positive 2x. That's going to be a positive 6x. That doesn't work, right? 2x and 6x is 8x, still not 7x. So let's switch their position. 3 and 2. Plus 3x, plus 2x. There we go. Excuse me, plus 2x, plus 4x, and there we go. That right there is our 7x. So this is ultimately our factorization. 2x plus 3 and x plus 2. Yeah, that's really what we did. We had to just guess and check. All right. Let's keep moving here. 4x squared minus 7x plus 3. And we're going to factor. This is maybe not as fun as we had yesterday, right? Where we were like, oh, we're jamming along. It was a little arithmetic puzzle where we were saying, oh, we just need 2 factors that have a certain sum. And it was kind of like, kind of reminded us of 3rd and 4th grade math just a little bit, right? We're not so lucky right now. Now, look at this. Now, the first question is, are either of these things prime? And I think that's the issue that we really want to really tackle again. Remember what prime numbers mean. Prime numbers are numbers that are going to have only 2 factors. 1 and itself. So 2 is the only even prime number we have, right? We actually just dealt with that. And then we start dealing with, because after that, think about all the even numbers, right? They'll all at least have not only just 1 in themselves, but they'll all even numbers will have 2 as a factor. So none of the even numbers will be prime. They're actually what's called composite, of course. So 3 winds up being prime. And I like to actually deal with 3 because we're going to put a 3 here and a 1 here, okay? And now we also see that our signs are negative, so it means that we have to do a negative times a negative here in order to get the positive. But it also means that what we had here was that we had to take a sum to get 2 negatives, right? So we would never have this. We never have a negative and a positive to get that negative, or this way, I'm sorry. Like if I had a negative 3 and a positive 1, right, that would give me a negative in my sum, but if you multiply those together, it's not going to give you a positive. So we know right now, just by process of elimination, that both of those second factors are going to be negative. So they have to be negative 3 and have to be negative 1. And now we're doing the experiment as to what goes in the 4x side of things, okay? The 4x squared. So let's actually just go through all the factors. 1 and 4, 4 and 1. So let's put in 4x and x. Which, by the way, as you guys can see, is different than x and 4x, right? But we'll start with 4x and x. Sometimes we get lucky. Product, negative 3x. Product, negative 4x. Gentlemen, that outer inner has a sum of negative 7x. We just lucked ourselves into the correct answer by just the way we set it up right there, okay? Kind of lucky. Sometimes they're really not that bad. Like, we'll get these ones too. But we'll be able to factor 3x squared minus 7x plus 2. And we're going to continue to guess and check here. I'm going to show us another method before we finish here that I'm hoping you guys will appreciate. That's pretty cool. but this is the way that is going to kind of be our default for now. Now, what's great is that 3x is prime, or 3x squared is going to have a prime leading coefficient, 3, so it has to be 3x and x. And then here, this is also prime. It also has to be 2 and 1. Now the question is it 2 and 1 or is it 1 and 2? Also, you have to consider this. This is positive and this is negative, meaning that both of these have to be negative. Okay, both signs. So the question is, where do we put the 2? So let's try 2 and 1. Okay? And I'm going to actually do this in black real quick just to differentiate. 2 and 1, so I have a negative 2x, negative 3x. Your sum here, right? When I do those two, that's a negative 5x. That didn't work. So it has to be. This will be the right answer as soon as I switch it. It has to be. It's the only other possibility, right? And watch what happens when we take our negative, our product. It's going to be a negative x. It's a negative 6x, which of course the sum of those two is negative 7x. So there, had to do use a little bit of reasoning, but we get our answer of 3x minus 1 and x minus 2. All right. It does get trickier. It really does. A few more examples. We're going to factor 3x squared minus 7x minus 6. Oh man. Well, here we go. At least we have a prime one, right? 3x and x. At least I'm saying, guys, because guess what? Your leading coefficient and the c term, that's the constant term, okay? And that's what you guys are going to start to hear me use this as. This is the a term, this is the b term, and this is the c term. How did I come up with that? Well, again, that's just the basic form of the quadratic, right? The x squared term is going to be the a term. So the a in this case is 3, b is negative 7, and c is negative 6. So that c term and the a term, right? The a term being prime, the c term isn't. Now, here's the trick. We know one will be positive, one will be negative. Okay? For now, I'm going to leave the signs like that because if we wind up with the opposite, we can actually just flip it. So if I wind up with a positive 7, I can flip it over. So let's go through our different iterations here. 1 and 6, for example, right? And I already can see that this isn't going to work out. This is a positive 1x, but this is a negative 18x. There's no way that's going to give me a negative 7, okay? So let's flip them. 6 and 1. 6x, negative 3x. When you put those together, it's going to be a 3x. That's not going to work. So let's now move to different numbers. 2 and 3. This guy's going to be 7x. This guy's going to be 2x. This is going to be a negative 9x. The sum of those two is negative 7x. So we have our correct answer right there. 3x plus 2, x minus 3. Now I want to show you guys something real quick. Just a little sidebar. If I had 3x at x, and I put this in, right, as instead had it as negative and positive, which is what it would be. In order to get a negative 6, it has to be a plus and a minus, right? If I had gone through and put a 2 and a 3 here, and I got negative 2x and I got a positive 9x, right? Those together are going to give you a positive 7x, which is almost our answer. When that's the case, it means our numbers are correct, right? And all we have to do, oops, let's not lose our correct number there. All we have to do actually is change our signs, right? And the negative 2 will become a positive, and the positive 3 will become a negative, and that automatically switches it over to switch our sign. Okay, so we can get actually what we had all along. So, just a little bit of a trick for you guys. Negative 9x squared minus 3x plus 2. We're going to factor this guy. Before I factor this guy, I want to get rid of something, and it's this. I'm going to get rid of the negative. So I'm going to factor out the negative so I can actually then factor two different binomials the traditional way, because our factoring method only really works well, and in our signs are going to get screwed up when we have the ax squared plus bx plus c, where a over here is a positive leading coefficient. So we're going to factor out that negative, leaving me with 9x squared plus 3x minus 2. Okay? It means I just changed the sign for all those terms. Now the negative still stays outside. And now we're factoring, right? Now, negative 2 is where we have our prime number, okay, between our a term and our c term. We had a prime c, which is great because we only have two possibilities, being 2 and 1. Now, if the positive and the negative are in the right spot, I don't know, okay? Hopefully they are. And then we just start throwing stuff in. Let's go 9x and x as my factors for 9x squared. Okay? 2x, negative 9x, that's not it. Okay? Let's flip it. X and 9x. 18x, that's not going to be it, right? A positive 18 and it's got to be a negative 3, right? This would have to be a negative 21. That's not going to work, okay? So let's abandon that. Other factors of 9, well, we have 3. So we have 3x and x, okay? Plus 2x, right? Minus 3x. That doesn't work. That's a negative x. So flip it. X and 3x. We have a... Oops, I'm sorry, guys. Why am I doing x and 3x? That would be 3x squared. We would need a 9x, right? We were doing 3's in both. Goodness, guys, this is too much virtual instruction for me. Okay, I'm sorry. There's only one way to go about this. This guy wants to be in 6x. This guy's negative 3x, right? Which is okay, because look, that gives us a 3x. That's this. That's what we needed, right? After we factored out that negative. So here we go. This is our factorization. Negative 3x plus 2, 3x minus 1. Okay. Not really worried so much about the word problem versions of these. I'm going to show you one more fancy way to go about this. We're going to have a 6x squared plus x minus 2. Let's take this guy. And we already know here that we have, and this is just a new method for factoring, okay? And this is factoring, and what it's going to use factoring by grouping, which is another method that we will discuss later, okay? And we haven't really utilized it yet. Factoring by grouping is really handy, especially when we start trying to factor, because I think some of you your imagination may be going to like, hey, what about when we have something with x to the third, right? A third degree polynomial. Can you factor that? The answer is actually yes, you can. You can do it utilizing this technique of factoring by grouping, okay? And here's what we do. Rather than guessing and checking, let's actually just take a product to start with. So I'm going to take the product of the A and the C, and that's going to give me, right, where I need to get negative 12, or I need to get 6, excuse me, I need to get x, but the product is negative 12. Goodness, I'm really melting down here. So here are my possibilities. 1 and 12, 2 and 6, 3 and 4. What I need to go through here now is figure out where I'm going to have this difference of x, and that's going to be here, of the 3 and the 4, which is a negative 3 and a positive 4, right? That's going to give me the positive 1, all right? Now that I have that, what I'm going to go back and do is I'm going to stick these guys into this original equation, and I'm going to use those to express my initial equation. So I had 6x squared, I had a negative 2, right? But to get this x, I had to add 4x and subtract 3x. That's how this is going to be achieved in here. Okay? Now that I have that, I'm going to factor by grouping. You know what? That's okay. I'm going to actually show that little route right here. Okay. So I'm going to have 6x squared plus 4x minus 3x minus 2. Okay? And I'm going to see if there's anything I can factor out of both of these. Now, if I rewrite this guy, I can actually factor stuff out of both terms. Okay? Actually, I don't need to rewrite it at all. But you know what? I always like and I have the positive one as the second one when I do these guys. Okay? Watch. Group them. This is one group. This is another group. What can get factored out here? Watch. It's going to be 6x squared. I can pull out a 3x, leaving me with a 2x minus 1. Plus, what can I pull out of here? I can pull out a 2 out of both of these, right? Leaving me with 2x minus 1. Gentlemen, look what matches here. This guy and this guy. Okay? Sidebar. Think about what we have here. If I have A times B plus C, that's the same thing in the distributive property as AB plus AC. Or think about it this way. If I have BA plus CA, I can take this A out, and then what I'm left with is I'm going to group my terms here, B plus C. Okay, so look, I have a 2x minus 1 that I'm going to pull out here on the side, 2x minus 1, and then I'm going to group my leftovers. Remember when I did that with B plus C? I'm going to group now with these other guys, 3x plus 2. Gentlemen, that is actually your factorization right there. Don't believe me? Foil it. 6x squared plus 4x minus 3x minus 2, which of course is going to be 6x squared plus x minus 2, which again is this, our original problem. So this is how you do this problem by factoring by grouping. Some of you guys are going to get pretty quick at these, doing it this way. If you can figure out this method, I'm happy to work with you more if you'd like. I'd examine this a little bit more, okay, before we get too crazy. I think at the very least, you guys can always kind of default back to that method where we're just going to guess and check. Because, you know, just it's going to take us a little bit more time. It's a little bit more time intensive. This way is a lot more deductive versus the other way is where it's inductive, right? We're just kind of guessing at it and waiting for it to not be wrong. So there we go.